So this is part 2 for chapter 16, and last time we were trying to understand, at least definitionally, how to find expected value and how to find standard deviation and variance for a discrete random variable. What we're going to do in part 2 is show you what it looks like given a probability model, and then how to add, subtract, multiply expected values, variances, and combine different variables. So hopefully this one video will show you how to utilize your calculator if you need to. And then the last video will be on a continuous random variable. So our focus on discrete. John Stone's Jeep Junkets charges $150 per passenger for a half-day tour of the Chino Hills countryside. Okay, so this is like a Jeep tour of a rocky terrain. JJJs, or triple Js if you will, vehicles hold up to 6 passengers, and the trips do not run until there are at least 2 passengers. It doesn't really make sense for them to run a business if they're only bringing one person out. So 2-person minimum. Given is the probability distribution for the number of passengers on a randomly selected day. So sometimes they have 2, sometimes they have 6, they have some time in between. So they keep that information, and then we can determine the probabilities. So on our notes, we see that we have 2 passengers, probability is 0.15. 3 passengers, 0.25, 4 passengers, 0.35, 0.2, and 0.05 for 5 and 6 passengers respectively. The simple question is find the expected value and the standard deviation of the number of passengers. So we go back to our formula and we say, how do you find expected value? So expected value is the value, so the number of passengers times the probability that it happens, and then this sigma means sum, so we're going to add up each of those probabilities. So we take 2 times 0.15, we have 3 times 0.25, 4 times 0.35, 5 times 0.2, 6 times 0.05, and we get 0.35. Over on our calculator, you can see that I have already done a couple things for us. We have our passenger as our column A, and the probability is shortened as prob, is in column B. So I have 2, 3, 4, 5, 6, and their probabilities. I can find each of their expected values by simply taking in A1 times B1. And what I did is then I copied this formula and I put it in each of the cells. And once I do that, then I can get this setup pretty simply. So this gives me each of the individual expected values, and now I want to sum them all up. So I say sum C1 to C5, and I get 0.35. Okay, back to the notes. If we're looking to find variance, remember, variance is the square root of the standard deviation. Variance is each of the values minus the expected value, or mu, or E of x, times the probability. So then once I found my expected value, now I can do 2 minus 3.75, square it, times the probability. 3 times 3.75, square it, times the probability. So what I can do in each one of these, if I have another column on my calculator called variance, I'm going to take the first cell minus the expected value, so it's 3.75, squared times the probability. And then what I want to do at the end is to sum up all of those values. So I get the variance to be 1.8175. And to find the standard deviation, which is what the question asked us, we want the square root. So if we take the square root of 1.1875, I get 1.09. We round up just a little bit. So triple J expects 3.75 passengers. Note, this is our answer in context per trip with a standard deviation of 1.09 passengers. I'm going to highlight the units again because what we're talking about here is how many people do they expect to take on an average trip plus or minus however much for our standard deviation. Whenever we talk mean and standard deviation, we should be thinking a normal model. So on our calculators, if we add a new document and we graph as a histogram, as a bar chart, our model, it should be roughly unimodal and symmetric, and that's what we see. So on our x-axis, we have our passenger number, and the y-axis is showing the probability counts. We've seen these before, so we should be able to do that type of representation. If you need help forcing your calculator to do this, don't hesitate to ask. Okay, so let's allow C to be the total amount of money JJJ collects on a randomly selected outing. So instead of just looking about passengers, let's see how much it costs. Since JJJ's or Johnstone's Jeep Junkets, it gets $150 per passenger, then our cost function will be 150 times the number of passengers in the car, where X is the number of passengers. So we take our probability model for just passengers, and we're going to multiply each one of those by 150. So if we take 2 passengers, we'll make $300. If we take 3 passengers, we'll make $450, and so on. What should we get for the new expected value for our cost and our standard deviation? So how much would we expect to bring in is the question. So we can find the expected value and standard deviation for the money collected by simply taking the probability times the cost. Well, this looks oddly familiar. So on our calculator, what I did is I took our cost function, and all I did was type in my variable, passenger, times 150. Notice that's in the equals line or the formula line, and it copied each of these values. Likewise, I can just type prob again, and it takes all of those values in. Now the next column, again, I'm just multiplying these two to get the expected value for each passenger, and then I want to add them all up. So my expected value is 562.50 cents. If I want to find the standard deviation, again, it's the square root of the variance. What I'm going to do is take each one of the values minus the mean, which is $562.50, square it times the probability. So this sigma squared is our variance of our cost, and if we do the exact same work that we did before, or if we look on our calculator, you can see the formula that I typed in. The first cell minus the mean squared times the probability. I do all of that, and I add them all up. I get 26718.80 cents. $26,718.75. Let's make sure I'm on the highlighter mode. Now, if I take the square root of that, I get $163.50. Now, you might be asking yourself, Mr. Swenson, that seems like a lot of work. Isn't there an easier way? And so if you go back to slide 23, so we'll go back 3 slides. Expected value, sorry, I want to go slide 21. Our expected value was $3.75, and our standard deviation was 1.09. How can I get these numbers? Well, it goes to the idea of how we could have saved ourselves time, is that if you know that expected value is just going to be a multiple, we can take 3.75, which was our expected number of passengers, times the cost. We could also take our standard deviation and multiply it by 150 and gotten $163.50, because expected value and standard deviation in this case are just multiples. Now note, we did say variance of cost times x, or some constant times x, I should say, is equal to that squared times the variance of x. And then what we are doing is we're taking the square root, which would give me the a times the square root of the variance. Which is why I can just multiply 1.09 times 150 and get $163.45. Okay, so we looked at a probability model for passengers. We looked at the probability model for costs. And we see that we could just easily calculate by doing a multiple. Well, let's say Mr. Becerro wants to form his own company called Becero's Bronco Bonanza. They're impressed with the success of Jeanette's Jeep junkets and decide to join the company with his Bronco. So now we've got a Jeep and a Bronco. Fancy new car. After a time, Becerra's Bronco Bonanza has found the following probability distribution for their car: 2 passengers, 3 passengers, 4 passengers, and 5 passengers. So they have a little bit less. We could do the exact same amount of work and find the expected value is 3.10 and the standard deviation is 0.943 passengers respectively. So the question then becomes, how many total passengers can Johnston's Jeep Junkets and Becerra's Bronco Bonanza expect to have on a randomly selected day if they combine their businesses? Now, let's bring these two models just in for their passengers. The Johnstone's Jeep Junkets could take from 2 to 6. The Bronco Bonanza can take 2 to 5. The number of passengers range then, the minimum for each car is 2, and the maximum would be 6 plus 5. So it would range from 4 to 11. We also know that there are 1, 2, 3, 4, 5 different options for the first car and 1, 2, 3, 4 options for the second car. So there's 20 total combinations of passengers in a Jeep and in a Bronco. We can get a total of 4 passengers or we can get a total of 5 passengers, but also note that ordering doesn't matter. So we have 2 plus 3 or 3 plus, or it does matter, sorry. So we have to actually do a little more work of combining these distributions. The goal is to come up with a new probability model for their businesses combined. We are adding them together to find the new expected value. So if you take a look, we have just saying if we have 2 passengers in the Jeep and then the combinations for Bronco Bonanza, then 3 passengers for the Jeep and then the same, and then 4, then 5, then 6. And what we want to look at is if we have 4, this is the only way of getting 4. And then our probability attached to it. If we have 5, 5, those are the only 2 ways of getting 5. So we will combine these 2 probabilities. Let's go with gold. We have 6, we have 6, 6. Those are the only ways of getting 6. Let's go with peach. 7, 7, 7, 7. Okay. Let's go with green. We have 8, 8, 8, 8. Let's go with light blue. We have 9, 9, 9. And then we're getting lower, so let's go with purple. 10, 10, and then 11. Just like 4 is only one way of doing that. So each of those colors, we need to combine their probabilities. Now, I'm not going to save you a little bit of work, and we're going to get this new probability distribution. This takes all of the new possibilities of passengers we could take in both the Jeep and the Bronco, and we are going to do the exact same work for the probability distribution. So on our calculator, you can see I have each of those. So I have 4, 5, 6, 7, 8, 9, 10, 11 with their new combined probabilities just from that combo table. And now I also have, more about that in a second, I could find their expected value. So on the notes, we have the exact same operation. The expected value is 6.875. Interesting. And the variance in the similar fashion is 2.0775. Well, if you go back to the formula, when we have the expected value of the sum or difference of 2 random variables, we are just adding the expected values. So if we knew the expected value for the first one, which is 3.75, we found that. And I gave you the expected value for Broncos, which is 3.10. If you just add those up, we get the exact same calculation. Now notice the variances add. So our variance for the Jeep Junkets is here. And the variance is here. Now you might be asking yourself, Mr. Swenson, on the previous slide, you said Becerra's Bronco Buster, if I go back here, is 0.943. This is the standard deviation of, let's say, B, or sigma B, if you will. Well, notice variances add. And so when we're back here and variances add, let's write that, variance adds, we need to square the standard deviations of both of these. Now this is the squared, this is the variance of x, or the standard deviation squared, of the Jeeps, and the standard deviation of the Broncos squared. And then to find the standard deviation, you take the square root of that, which is 1.441. Again, these two numbers are the passengers that we would expect. So combining their businesses, we expect 6.85 passengers on a randomly selected day with a standard deviation of 2.07 passengers. Now, if Becerra also charges $150 per passenger and also pays $100 per trip in fixed costs, now they're both charging $150 per passenger, and now it costs each business $100, so we're losing $100 in cost per trip. I want to find the net profit. So I can take the cost and find the new expected value. And I can see on my calculator I have a roughly symmetric distribution. And what I want to do is then say, what is the profit here? Well, we have the expected value is 6.875. Highlighter, 6.875. And we know the standard deviation is 2.0767. So let's just do the formula. We know that the expected value is going to be $150 times 6.875 minus the cost. This is a scale and this is a shift. The mean gets both of them. And we'll end up with $827.50. Our standard deviation, however, only gets, think standard deviation is the spread, only gets a scalar. If you have add or subtract 200 to everything, the shape is not changing. So we take our standard deviation, multiply it by 150, and we get our new standard deviation. And now, if we assume the daily passenger numbers are independent, unimodal, and symmetric, we can apply a normal model. And so if we look at the distribution of our costs, we see that it's roughly symmetric and unimodal. So we can apply what we know about our normal model. If I take my normal model, which is at our mean with our standard deviation, we get our nice bell curve. So the question then becomes, what is the probability, let's highlight this, the last question is, what is the probability that Johnstone and Becerra combined will make at least $1,000 on a randomly selected day? At least means I want to be above that value. So if you take our model that we have, either a standard normal model, which remember is centered at the mean of 0, standard deviation of 1, or we take our $827.50 with our standard deviations, we always draw a picture. We want to know where is it, what's the probability, or what's the shaded under the curve of greater than this z-score. So we have to go back to z-scores. Remember, z-score is what we want minus our mean over the standard deviation, or what we want minus the expected value over the standard deviation. So we get a z-score of 1.2195. And so this goes to probabilities given z-scores. What's the probability we have a z-score greater than or equal to 1.2195? Well, how do we find the area under the curve? On a calculator, we're going to go Menu, Statistics, Distributions, Normal CDF. And this time our lower bound is 1.2195. And our upper bound is a large number. We standardize it because this is a z-score, 0 to 1. We hit OK, and we get our probability, which is the chance that we make $1,000 in a given day. Now you might be saying, I don't like doing that. I don't like converting it to z-scores. Well, luckily I can take that exact same value and I want to know what's the probability we make at least $1,000, and let's say the upper bound is something very large, and instead our mean is $827.50 and our standard deviation was $141.45. And notice we get roughly the equivalent value, 11.13%. So whether you want to standardize this or you want to utilize your expected value and your standard deviation, we are still doing the same things we were doing in chapter 6 when we learned about the normal distribution. So this was a long video for one problem, multiple stages. We learned what shifters do, what scalars do, what happens when we add random variables together, what happens to their expected values, and their variances. Remember, I keep going back to standard deviation. Standard deviation, or S sub x, is the square root of the variance. Okay, we've got one more video that's talking about a continuous random variable to finish up this unit. So I'll see you in part 3, Falcons.